everyone. Welcome to Climate Chat. Dan isn't here today. Stacey is. I'll first give a short presentation. Then we'll be joining us again in 2 weeks. Next week we will have a pre-recorded recording on what was again the bias about biases. About optimism bias, this one. We already had this conversation last week on Monday, and I think it was really interesting. So please tune in again on next week. It's pre-recorded, but it's quite interesting conversation, and you can just comment like every time. It will be broadcasting live. Now to my presentation. There we are. Yes, so I want to talk here about generations of global warming. And what you see here, I made this graph showing the warming stripes, like I showed last week. But then showing for every generation of my family, starting with my grandfather, and then my father, and then me, and then my son, is showing the warming stripes during their lifetimes. And I think this is quite an interesting way to look at the data, because then you see how these different generations, the generation is about 30 years, so every 30 years now people reproduce and a new generation starts. And so every generation of 30 years, you can see the climate changing during this generation. But of course, it's not just the climate that has changed, but the world has changed a lot over this time period. And I think it to me, it really helps, during Christmas with the New Year to think about this, to ponder about these different generations and how, look back and to see what you learned from your family, how they grew up, what was the context. Because often when we talk about climate change, often the older generations are blamed for what they did, right, or for all the greenhouse gas they put into the atmosphere and how that will impact us and how it's already impacting us. But it's to me, it really helps to look back and see, okay, what context were they operating in. So my grandfather was born in the 1920s, just before the Second World War. I think he was about 10 years old when it started in the Netherlands. And you can see, if you look at the climate at the time, it was already warmer than the pre-industrial. Here I use NASA data, and the baseline as used by James Hansen is called this from 1980 to 1920, which is a reference period based on a NASA data set, and because there was a volcano, there was some volcanic activity at the start of the 19th century, so there are some that caused some cooling, so that compensates a bit for the warming that was already started. So I think that's in my opinion, quite an appropriate baseline for the pre-industrial period. And then you see that my grandfather grew up, it doesn't go much below zero. So that means it didn't go much below the temperatures. The black line is the 2-year average temperature. So the global temperature didn't dip much below the pre-industrial, or below the pre-industrial temperatures, right? Of course, monthly there is some dips, some more dips, but and it's the same is the case for my father, and I'll get to that later. But I think that's quite in a way mind-blowing that the climate didn't really start to change much above this, above half a degree until the 1980s. And yeah, my grandfather, I'll get to that. He grew up during the war, and and the things that happened to him made him a pacifist. And then during just right after the war, the Dutch had to go into military service, and my grandfather really didn't like the military, and there was this colonial war still going on with Indonesia, which was the greatest colony, the largest colony of the Netherlands, and they were fighting for independence there, and so my grandfather didn't want to go, and he didn't want to fight, and then they put him in this because of that, they put him in this asylum, and they gave them these shocks, these prefrontal cortex electrical shocks to try to have him behave better. And yeah, that impacted him quite a lot. He didn't really suffer brain damage, but that really also changed impacted his view of the world. And my other grandfather, who's not here, but this is from my father's line, the father of my mother, he did go to Indonesia to build bridges there. To me, that feels so distant, but it's that was end of the 1940s, so it's only 80 years ago, and yeah, so I think that also helps to see the world they lived in, they grew up in. And my other grandfather from my mother's side again, he started working in the coal mines in the Netherlands, in the south of the Netherlands, because that was the main energy source they used at the time, and they needed a lot of strong men to work in the mines, and there was quite a respected job at the time. You cannot really imagine that now. And then my grandfather, who's shown here, he became a math teacher. And then the greatest gas field in Europe was discovered in the north of the Netherlands, which is the Groningen or the Slochteren gas field. And then the mines were closed, and then the Netherlands really switched very rapidly to what some call natural gas, but fossil gas, methane, CH4. And you can see that here in the 1965 onwards, you see this enormous spike in energy consumption, and that's really driven by gas. So you had all these commercials and all these incentives to switch from coal burners to gas burners for your heating and for your cooking, and this switch really happened extremely fast. The unit here is terawatt hours of energy, primary energy, and then here's the time, and you can see it in the 1980s. There was this, there peak, and all these. There was the first peak. You see here the crash from the oil prices. So there's a lot. You can see a lot happening with simple data presentation like this, right? And then so people started to get central heating, and much of that gas was sold on the European market really as fast as possible. There were these gas contracts. They were almost like giving it away. And why was that? Because what they thought at the time, or what they envisioned, was nuclear power was coming. And then once the nuclear power was there, it will be impossible to market that gas. It will be practically useless. Because of course, if you have E equals mc squared, you can get a very little bit of mass. You can turn into a lot of energy. And yeah, of course, we'll get to that, but that didn't really happen. And then in 1960, my father was born. And he, as I mentioned, you see that the temperature during his life, so the first 18 years of his life, didn't reach above 0.5 degree of global warming. There was warming, but there wasn't that much warming. Right, you see here this peak, and of course there's so much more uncertainty the further you go back, but it really started only warming later. And in 1972, so when my dad was 12 years old, the Club of Rome published this report. It's called The Limits to Growth. I'm a member of the Dutch chapter to the Club of Rome. Now, and then you see here, this is carbon dioxide concentration in the atmosphere. I've shown this before. Here, these are the measurements. These are taken from ice core data, I think, and then here these are measurements from models. And then these are measurements from Mauna Loa. So then this is the famous Keeling curve, right? The observations from Mauna Loa on this volcano when the volcano is not active, and they take these air samples on this volcano because it's pristine air, and it provides an accurate sample of the CO2 concentration. And what they modeled at the time for the Limits to Growth report was there's an exponential growth in the rate of CO2 increase, which was an important pollution indicator at the time. They didn't know much about the warming effect of this yet. It was still relatively unknown, of course. But they did model CO2 increase. And then these are the observations until last year, 2025. And you see that these are really like almost, it is because of a volcano caused some cooling, so there was a bit of the oceans took more CO2. So, and then of course it hadn't increased exponentially, but it's still increasing more than linearly. Still increasing, the CO2 in the atmosphere is increasing still faster and faster. But that's of course, as those listening to this show now, I hope you know quite well already, is that it's not just climate change is not just about CO2 or greenhouse gases. The regional impact, but also the global climate is also impacted by aerosols, mainly sulfur aerosols, sulfate aerosols, which cause cooling. Here you see on the y-axis the fossil fuel CO2 in billion tons per year. So my grandfather was born around here, and then you can see the CO2 emissions in blue. The CO2 concentration. Those emissions. CO2 emissions you see rapidly climb after the Second World War, and then they have kept climbing, right? And here you in red you see the sulfur emissions in million tons per year. The sulfur is in the fossil fuels, mainly in coal and oil. So if you burn the fossil fuel, the sulfur is released. And then what happened in the 1960s, 70s was that, of course, there was some cleaner fuels used or more gas. So much of the increase was gas powered rather than coal powered. And then, of course, there's not much sulfur in the gas, and then you have less sulfur emissions. But what also happened was that the coal-fired power plants started to install, especially starting in Western Europe and in the United States with these clean air regulations. In the United States, the Clean Air Act, and we have similar regulations in Europe nationally, and now with the EU as well, where the amount of air pollution that can be emitted is restricted because of health impacts and because of the acid rain, the environmental impacts. But that does cause a reduction in the cooling impact of these sulfur emissions. So these are global fossil fuel emissions, and here is the same for shipping. And yeah, you see here it started with billion tons of CO2 again. You see that here the CO2 emissions were first higher than growing faster in a way than the sulfur emissions compared to here. And that was because it was at the start of this period, and so that's even before my grandfather was born. The ships were mainly powered by coal, and the coal emits more CO2. It's more CO2 intensive, and the oil also emits, of course, a lot of CO2. You see a dip, and of course it's also because of the war, the Second World War. But then you see that there's the CO2 and the sulfur dioxide grow more or less in sync until regional regulations came into effect. There's an economic crisis, I think, this shows in this dip. But then in 2015 or 2010 and 2015, you had these regional sulfur regulations. So already you see the sulfur emissions decrease. And then, of course, here in 2020, talked about it a lot here on the climate chat, you see this enormous decrease. And that's because of the global sulfur regulations, where they could only emit, instead of a maximum of 3.5% maximum sulfur fuel content, it decreased to 0.5%. So they were the ships, 60,000 very large ships that transport goods around the world and people around the world, cruise ships included, they emit much less sulfur now. And then we get to me. So I was born in 1987. So still, most thought at the time, there was some discussion started on whether the warming, the human influence on the climate was visible already. That was right when I was born. I was born in 1987. This is James Hansen in 1988, giving a presentation to Congress, the United States Congress, where he told, he was a director at NASA, GIS at the time, and there he told about that global warming is here and that we need to take it seriously and we need to do something about it. So that's 37 years ago. And now you can, these are the radiative forcing that showed this graph also last week. If you want to want more details about this, but what it shows is in watts per square meter, and watts per square meter is the forcing. The forcing is what forces the climate to change, and it's expressed in how much energy is pushed into the system by the greenhouse gas. These are the total greenhouse gas forcing is now 4.1 watts per square meter. That means that the greenhouse gases force down about 4 watts per square meter of energy into the system, into the Earth system. And then Here you see the aerosols, and there's a lot of uncertainty of how much. This is the biggest uncertainty in climate science, mainly because of the impact of these aerosols on clouds, because aerosols impact cloud formation, and these clouds, they can brighten if there's more particles for the water droplets to condense, but they can also rain out faster, or they can last longer. So there's a lot of uncertainty there, and that's why the NASA satellite data is really valuable, because they look at how much sunlight comes in and how much sunlight is reflected back to space, but also how much infrared radiation is going out to space, and that results in the Earth's energy imbalance and the change thereof. And what we presented in our 2023 paper, Global Warming in the Pipeline. We presented a method of assessing how strong this effect is, by looking at mainly these regions of where most of the sulfur is emitted, was emitted by the ships, because that provides an inadvertent aerosol experiment. So an opportunity, in a way, scientific opportunity, to reduce the greatest risk in climate science. Let me change to this. I hope you can still see it. Because we need to know what causes these changes. If you look back again, looking at the generational changes, when my father was born, the net forcing, even though the greenhouse gas forcing was increasing quite rapidly, of course, not extremely rapidly. It started growing much more after 1960. Not saying there's a causation with the birth of my father there, but of course you see that around this period, the greenhouse gas forcing started to increase faster. 1960, 1970. Of course, it's also because of the growth, industrialization of China, etc. But the net forcing, so of greenhouse gas and aerosols, was very low, because especially if the effect of the shipping emissions is stronger than the best estimate of the IPCC, so including Hansen is strong estimate of about 5.5 watts per square meter of forcing, radiative forcing from these aerosol decrease, compared to the peak of the sulfur emissions of shipping around 2010. Then you see that almost the forcing was almost close to zero, right? It's, of course, it's still positive, because there was warming, but there was very little warming, even though the greenhouse gas forcing was still quite high. So again, I want to talk about one more thing here. I want to show you this, because of course in 2001 something happened, and I think you know what I'm talking about. I'll let George Bush talk about it here. Or this happened. Bush talked about it.
We do not know how fast change will occur, or even how some of our actions could impact it. For example, our useful efforts to reduce sulfur emissions may have actually increased warming, because sulfate particles reflect sunlight, bouncing it back into space.
Yeah, of course, it's most of you were thinking about 9/11. Of course, it also happened in 2001. But before that, it was a bit of a bad joke, but before that, George Bush already talked about the impact of the sulfur emissions. His father before him introduced the Clean Air Act or strengthened the regulations of how much air pollution could be emitted, especially sulfur. So I think it's quite interesting to see George Bush Jr. Talked already about this impact of the sulfur emissions, reducing these emissions, causing more warming. Especially if you compare it to politicians and not just from the United States, but from any country. I think this is the only president or head of state I've ever publicly heard talk about this, and I'd be very interested to hear if you know anyone else. But yeah. So then. So it kept increasing. Warming kept increasing, and I think this is also, again, during my grandfather's lifetime, and or his youth, and my father's youth, there was not much warming. But then around when I was born, and again, James Hansen was early to call this, to say that it's already the impact of our greenhouse gas emissions is starting to become visible in the global climate, and it's the warming is starting to show. And of course, it was also around that time was also the end of the Cold War, and I think that's also worth a mention, of course, because the Cold War ended. I think 1990. I was too young to remember, but I was in the south where my grandmother, all the grandfather worked in the coal mines in this region 2 weeks ago with my family, and there are these mines there, not just coal mines, but also these it's these chalk mines. And there's like 200-300 meters of mines, and it's this soft rock, similar to what the cliffs of Dover are made of these compressed shells, and you can find fossils there. But and they use these rocks to build churches. But what I learned when I was there was that in these caves, these man-made caves, these hundreds of kilometers of caves, there's also this United Nations complex. It's not used anymore, but it was there during the Cold War as a bunker, as an operation room for if there would be a global nuclear war. And it was like 400 offices there, and there was room for 15,000 people. And to me, that was really it helped me a bit to understand that time better. Of course, you know about some of the rockets, all the nuclear weapon testing, and all the rhetoric and the threats and the placement of these arms. And my father, he also went into the army, and he became a tank commander, and he had to defend the Iron Wall. Luckily, there was never a war, but when he passed away, in his jacket, I found these like testing kits to see how much radiation there is. So there's all these relics and from the past, and if you look at it from that perspective, they were very much focused on that. Of course, we were very much focused on the wars at hand and the danger of the bomb, and there's no excuse, of course, for not caring about changing the climate system faster than it has changed at any time in known history of our planet. But is the context, and it all, to me, it also helps to understand a bit what's happening now, and that we see less and less attention again on the things that matter. And I think that's also why more war is quite dangerous, not just for the sake of war and the impacts thereof, but also because it could have very serious consequences for attention to the bigger challenges in the long term. And now here, I want to go to my son. So my son was born in 2018. He just met my father, but my father passed away 3 months later, unfortunately. But he did spend a bit more time with my grandfather, and but he lives in a climate now. He grew up he's now 7 years old. During his lifetime, of course, the temperatures were already 1 degree Celsius warmer than they were at the start of the Industrial Revolution, let's say, again, at the baseline period, at 1880 to 1920, the pre-industrial baseline. And it's growing now. If you can see it by eye. You don't even have to do any statistical analysis. You can see already that the rate of warming from 1970 to about 2010 was quite linear, and then now it's increasing. And of course, we explained that in detail why that is, because we increase greenhouse gases, we continue to increase greenhouse gas at a record rate, and we reduce the cooling impact that was masking the warming of the greenhouse gases. And of course, there's also these feedbacks coming into effect, especially this cloud feedback showing that a rapid increase in global heat uptake. And we see it also in the ocean heat content, which reached another record this year, and might also be a record increase, a record rate of increase of the ocean heat content, and the oceans take up 90% of the heat of global warming. So yeah, again, and the next question, of course, is like, what will we have to look forward to, right? What will we be living with? Maybe even just when my son is 30, when the next generation is due, let's say, and yeah, so we think that we see that there's acceleration. We predicted already in 2022, based on that there's more heat accumulating in the Earth system. We expect the rate of increase to increase as well, temperature increase to increase as well. But this year, or last year, of course, and we talked about that as well here, that the German Gesellschaft, so the physical union and the meteorological union, they warned about the potential of 3 degrees of global warming by 2050. And this was really remarkable, even just for these different unions to put out such a statement. They worked on it for a long time, and they are really taken seriously, and they should. And they put out, for the first time in a very long time, a combined statement where this was like one of the main headlines, whereas they want, right? We really have to take the potential of 3 degrees in 2050 serious, and that's so that's when my son will be about that time. My son could, if he wishes, start the next generation of my daughter. So that's really mind-blowing, again, that you have the rate of warming that took 90 years, over 90 years, we could see that happen in the next 30 years. And the chances of that is much bigger than zero. So because the Earth's energy imbalance has more than doubled, I think the more data comes in, the more likely it seems to me that we could, of course, I can still be alive in 2050 as well to see my grandchild. To have a picture like this, right? We could face already twice as much warming, and of course that the impacts will be much bigger. Then it's not that if you have twice as much warming, the impacts will be twice as much, but it's likely much and much worse. And as this German physical and meteorological unions also mentioned, to discuss, they called for discussions on the withdrawal from low-lying coastal regions on the North and Baltic Seas. This was directed at the German government, but of course the Netherlands is also already for 30% below sea level on the North Sea. So that's really, we should really take that seriously as well. I'll get to this maybe later. So thank you for listening. Please don't forget to like and subscribe. Really, really, please do. It's not something we just say so because everyone else says it. It really does help if you do. And now maybe Stacy can come in to talk about the question. Oh, wait, let me see. How do I find her? There you are.
Hey.
Hi, Stacy.
Hi, Leon. Thanks. That was so great. And I am I'm not really a slacker, but I was getting stripes envy, and I was trying to do one of my own, and I'll have to post it later. But I was looking at it a little bit differently. The sort of the reverse of the storms of our grandchildren, more like the pleasantness that was previously enjoyed. You had yours stacked up so the years matched. I have mine stacked up so the ages match. So it's like, what was childhood like for my grandmother, and what's it like or for my daughter, like, and where we know that's headed, that kind of thing.
That'll be interesting to see it. I don't fully grasp what you mean, but
I'll show it to you. It's just more like yours is what was happening in the world, and so the lines go the same when all of you overlapped. You have the same line top to bottom. Mine, the start line changes because it's based on when we were born. And so it's just take all of yours are right justified almost, and just slam them to the left, instead of making the years, you know what I mean? I'll show you.
It's hard to understand it by
and also, or maybe I'll flip over at one point, but I should do what I'm here for, which is talk about what people have been talking about online.
You can ask the question first yourself if you like.
Well, how do you, mine is going to be more philosophical, I guess. I didn't realize that the largest oil field was in the Netherlands. I knew, what's that?
The largest gas field in Europe.
Yes, that to me, like, I knew Shell, but I didn't know that was the biggest. So between that and your grandfather working in the coal mines, how, like, is it just we didn't know, and we don't know, or we didn't know, or they didn't know, so that's what was done.
Yeah, of course it's I could have made the presentation much longer. So of course we were living in a place that was quite cold already. We had very cold winters, right? Especially when we started burning more and more sulfur-rich uh, coal that caused some even more cooling and even colder winters. But then, so we needed the energy. I wasn't born yet, right? But
Mhm.
and of course, in a way, people didn't know. I think now we don't have that excuse anymore. And the gas
Yeah.
field is this large gas field, and even at the time, there were, for example, um, known challenges of course, depletion. The limits to growth report was about there are limits to how much energy you can take, for example, from an oil field. You can, if they will deplenish, right, or from a gas field, and people couldn't really imagine it. But the book is very well written. I recommend everyone to just read the original
Mhm.
version, not from 1972, if you want. And then it explained that, yeah, of course, if you keep using energy from a finite resource, it will run out. And then, of course, now in 2016, it was depleted by 80%. And now they warned about it before, but so I learned that from my geology classes that the land will sink if you take out all this pressure from the ground. You take out these uh, what is it, billions of cubic meters of gas. Of course, the ground the ground sinks. So if you have sea level rise and sinking ground, you have more faster sea level increase relative to the land. But also there's earthquakes, and people homes started to show cracks because of these earthquakes, and then they just shut down the exploitation of this gas field. Now, of course, and the war in Ukraine happened, and now we're importing all the gas from Qatar and from the United States and from Norway and from our own fields in the North Sea. But what I think was really I wanted to also mention that is really important here is the nuclear power, because what I realize more and more, and again, there's no excuse, is that a big part of the fear for nuclear power, because is if you look at the data, it's one of the most safe ways to produce electricity in the world, right? Comparable to wind and sunlight, solar PV, but it's centralized, so there's advantages and some disadvantages. But the fear of that is also very much based on the fear from nuclear power, from nuclear weapons. And if again they were planning to replace all this gas use with nuclear power, and they built these nuclear power plants, and one was even finished, but they turned it into an amusement park because of all this fear, irrational fear. So I think we've now come to a point where we need to um, learn from the past and stop fearing some of the solutions. Right, we talk about that here often, even if it's uncomfortable. Right, and again, yeah, it's understandable if you go up with the fear of a bomb falling and destroying everything. I get it, but it's nuclear energy is really safe, and there are all these ways. Of course, we don't live in Soviet in the Soviet Union anymore, where they are just like playing with a nuclear power plant. Right? So yeah,
Um,
I wish for my children that we would take a more rational approach towards energy, climate, international development, etc.
okay, so that leads to another question then, because if if Dan were here, he usually says, well, renewables are more quickly deployed and they are much cheaper. You don't have the concerns that everyone, raises about. And so how do you answer that? Like, are you still nuclear or all of the above non-carbon?
I have 84 solar panels on my roof, right? But the past days, when they were covered by snow, we had the coldest night in 5 years last night. There's a lot of snow,
Wow.
and most days they produce literally zero, nothing, or just a few watt hours per day, right? And so, and we do need energy at this time of the year as well, right? Because now
Yeah.
we produce all this electricity when nobody needs it during summer, and then during winter when we heat our homes and use more lights and of course our cars, even our electric cars, need more energy during winter. And there's more rain, so our pumps need to work harder to keep those 30% that's below sea level dry, right? All these things, we use much more energy in winter, but then the sun doesn't shine. Of course we needed solar panels, and of course we need windmills because we're still burning so much gas and coal and oil. But we need all of the above. We also need nuclear. If you look at Germany, if I drive through Germany, I have some family there. My aunt lives there, and if I go to her, I pass by these what I call the model of the Energiewende. Energiewende is the German transition away from nuclear power mainly. It's often presented as away from coal and to renewables, but it's really away from nuclear, replacing nuclear with renewables. But that makes them more dependent on the weather, increases the prices, but they still burn a shitload of coal. Again, if you drive south to Germany, you have these enormous. I think most of you've seen these pictures of these enormous. It's worse than Mordor, right? From the Lord of the Rings. It's like this. You cannot really, even if you're there, if you're standing there on the cliff edge. I've done that a few times. You cannot imagine how large these open pit mines are, and there's many of those in Germany. So that's we can talk about all renewables all we want, and we should put them. The Netherlands has more, or I think now about equal as much installed solar panels as all of Africa, right?
Wow.
It's criminal gross negligence, right? The Germans and other countries took away the possibility of developing countries to develop nuclear power by not financing it through the World Bank or through national development banks. And then they also hoard all these renewable power supplies and close their own nuclear power plants. And then they keep burning fossil fuels like there's no tomorrow. And that's what's happening in the real world, right? I'm just observing what's happening. Again, of course, there's some growth in renewables, but the fossil fuels are also still growing.
Yeah, I guess and it's funny when we talk about developing nations, I just keep thinking it's so unfair. It's so unfair. Like and it would be cheaper to deploy anything there. So we should be investing and
It's all
giving it,
right,
giving it to them because it's cheaper and easier to do it in developing countries than it is here at home.
Yeah, they pay much more for light or for cooking fuels or whatever than we do. But you think everything is cheaper there, but often especially if you're relatively to what they earn, but often even just from a financial perspective, if you have these, for example, these oil lights, yeah, that's much more expensive than our electricity powered light bulbs, right? So they pay more for their services as the product as a service, or for light, for right? The service of having light is more expensive there than it is here. Cooking food, right? If you calculate the time, all the time spent by these about 1 billion women still using biomass for cooking, so 2.5 billion people still eating food that's cooked on biomass fires. All the time they spend on collecting the firewood and sitting in this fire, trying to keep the fire burning, and all the harm it does. 4 million people, mainly women and children, die every year. While the alternatives are there, right? It is criminal, but yeah, I think now we are got to the point where even solar powered cooking will become cheaper, and yeah, I think we're reaching the point where they can develop in a sustainable manner. I spent a lot of time in Ethiopia when working on solutions like this, and yeah, we are reaching that point, but it's taking much too long.
Yes. Um, the Scott had a question. The Dutch are known for their engineering skills. Since sea level rise seems inevitable, what is your country planning to do with this problem? There must be 1,000 plans already, I would guess.
Yeah, there's I think there's retreat. Yeah, so that's like give parts of the Netherlands back to the sea. That's one of the plans, and so we are really good at planning. But I think the plans are not. So I've been talking about it for as long as for 18 years, I think, about this approach from the Dutch government about on sea level rise, and it's always like 1 meter, or maybe 1.5 meter in 2100, right? But it could happen so much faster. In the past 20 years, um, the heat accumulation in the oceans was about 200 or 250 zettajoules of heat. If all that heat, and that's hypothetical, but if all that heat had gone to the melting of of land ice, sea levels would be already 2 meters higher. Just to
Wow.
give you an indication of how much energy the Earth, how much heat the Earth accumulates, and if more of that heat will be directed to the melting of land ice, and then you have all these albedo changes, right? Less reflective ice and more melt. We could see much faster sea level rise, and of course from further warming as well. So then, yeah, of course we are planning to build cities on dikes, new cities, in a way like Tehran is moving their city, right? We are also looking at the world, and of course, often there's these crazy plans that one guy developed this idea to build a mountain on this artificial island we build in the southern sea, where there used to be sea. They want to build a mountain and then also use it for hydroelectricity. But completely ridiculous. But there's many ideas. But I think what's really crucial there, and I'll be talking to some people here as well about that in the Netherlands, is that we underestimate the rate of change. And we can have all the plans, but we really should take the basic assumptions into account, and that will show that we need to act much faster. But yeah, you can look it up. I think there's many plans you can find online. I know some people who worked on those.
Let's see, one of the other ones. Level EK Web. How does it affect the Netherlands if AMOC slows down or does not? Sea level rise versus freezing over. That would need completely different mitigation actions. Is that correct?
Yeah, I think it's not so simple as to say either we freeze over or we have sea level rise. Because if the AMOC slows down, that would increase also not just from warming, but the distribution of global sea level. This is ocean heat, ocean temperature map, but you also have these of relative sea level changes. Because the sea level, when we think about global sea level, we might think that the sea level increases everywhere about the same, but that's not true. The sea level, it's very much dependent on ocean currents and on where the ice melts. And if the ice melts in Greenland more, then you lose some gravitational pull from the Greenland ice sheet, and that would also reduce sea level uh, more north, and it will increase sea level in the south, and vice versa. We have Antarctic, for example, West Antarctic ice sheet melting. You lose mass there, and then the water will go here. So, so you have to take these things into account as well. And I was thinking about that as well, about this, of course, when we had this relatively 8 degrees Celsius below zero isn't much, right? It's not very cold, but to us, we haven't seen that for, again, 5 years. And of course, then you think, okay, well, what would the real winter look like? Or what did the real winters look like? We had these ice skating competitions through 11 cities and they haven't happened since I think, what is it? Yeah, a long time, 1990 or so. Again, I don't
They
really
haven't happened
No, they
because there
used to.
hasn't been enough freezing.
Yeah, let me check the last Elfstedentocht, the last time. Yeah, so this is like our culture, like this biggest cultural competition. Yeah, it was really like. Can I show it here? It's like it was 25 years ago in 2022, so that's very long ago. 2022, that was from 4th of January, so 4 years more. Let me show you. So yeah, this, of course, my kids went ice skating today. It was the first day it was possible, and probably tomorrow it's too late again. It will not freeze probably, but it will melt probably if it starts raining tonight. 1 second. What was the question again?
That was about the AMOC.
Yeah, about the AMOC. Here it is.
Different preparation versus sea level rise.
So 25 years ago, so we had this ice skating competition, and it was also all nice and cultural, but and the way our culture is disappearing, right? That's part of our culture. It has already disappeared. It's now 29 years ago. So yeah, it's almost a generation ago that people, of course, some people still do it when the ice is thin, but like these real, like these competitions with thousands of people on the ice, they don't happen anymore because it's not safe anymore, and it's
you couldn't have an organized event. It's just
the
crazy
ice is
people
not
at
thick
your own
enough.
risk.
So you cannot drive your car on the ice anymore, right? That's the things they used to do in the Netherlands when there was when the real winters were there.
That's crazy.
But so what's strange are these winters. So we could get really extreme winters when the AMOC shuts down, and there is quite a strong indication that it's already slowing down, and also that it will slow down more when also because of the reduced aerosols, because there's less compensation of heat transported northward. And then what we could really have is much colder winters, but still hotter summers from global warming. And some say that even agriculture will be almost impossible in much of Western and Northern Europe. And because that's really the enormous. We talked about this many times here. It's an enormous amount of energy transported northward through the Atlantic Ocean. A petawatt on average at the peak, so at the start, and that's and now it has potentially already halved. If you look at the ECMWF data set, it should come out now. Check the website; it wasn't working yet, but you see that it's still decreasing quite rapidly, and that's that's a lot of zetajoules of heat per year.
It's crazy to I mean, when I started doing this with Dan almost 5 years ago now, I well, I hadn't even heard what the word or term AMOC, and then slowly it was like, oh yeah, this might shut down someday, blah blah blah, whatever. And now it's like in that amount of time, we went from maybe by the end of the century it could happen to it's very likely to happen mid-century, or the beginning of the shutdown, which is just it's mind-boggling.
Mm-hmm.
Another question was, what is the probability from Peter? What is the probability of reaching 4 degrees Celsius by 2084? In other words, what is the probability of 0.5 C degree increase every 10 years?
But it's hard to put a number on that, I think, right? Because I think it's not very high that we will have a half a degree continue, but I at least I hope. I don't know. That's the point. I think that we talked about it many times here that we don't know how much cooling those aerosols cause. It's the biggest uncertainty in climate science. We have an idea about the warming effect of greenhouse gases, but we don't know how much cooling those aerosols cause. Even that effect is much stronger, especially over the oceans, which take up 90% of the heat. And if you take away all these aerosols over the oceans, then you have much faster warming of the oceans, right? And then so more heat uptake, and that heat will also go into back into the atmosphere and start melting ice sheets, especially those who are underwater with the base. And it also depends on where does the energy go. If more energy goes to the melting of ice, we might, of course, we have the albedo feedback, but we might not. The warming might not be as fast. If the AMOC slows down, for example, the rate of warming could decrease because more heat will stay in the southern hemisphere and so stay in the ocean, but also more heat will melt ice. Ice melt, global heat uptake will increase. It sounds counterintuitive, but if you have more heat in the south melting ice and less heat in the north warming the land and the atmosphere, you can have more heat uptake and less temperature increase. So I think it's very hard to put a probability number on that. But it's not. I think it's much higher than zero. It's much higher than the chance of your airplane crashing when you board a commercial airliner, right?
Right.
So it's really. I think there's really a significant chance that we will have half a degree of global warming for most of the century on average every decade.
Frightening. Just
And it depends very much on how unlucky and on how stupid we are. I call it the unlucky and the stupid and unlucky scenario where
well, I'm
where the
pretty
climate
sure we can
sensitivity,
bank on the stupid. So there's
and
really
also
only one variable at play.
I think humanity can surprise as well, right? We also that we are able to figure out E equals MC square and turn it into both weapons of mass destruction, but also free electricity for all virtually, right? Compared to what energy costs or for people, for my grandfather when he was young, right? How much you paid for energy at that time, or still pay for energy in developing countries if you have to buy your wood, for example. The value of energy is very high, and the potential cost of producing electricity, especially, is really cheap. Our solar panels, sometimes, often during the year, we have to pay money to when we feed it into the grid, because nobody wants the electricity, because they all have their own solar panels and the grid is overloaded, right? So in a way, from the solar panels, the electricity prices are negative. If you have to buy it, the prices are negative. You get money when you use electricity. You have to pay money when you feed it into a grid. It's quite strange.
What? That
Yeah,
doesn't make any sense.
it does. Supply and demand. We live in a capital system, and but yeah, if you so, or you're overloading the grid, and yeah, you have to they have to make investments in the grid, and the price are negative again.
This is in the Netherlands.
Yeah, would we have, like, I think the highest or the second highest per capita installed solar panels in the world,
Wow. That's wild. I would not, well, per capita, yeah. But I still wouldn't have
and more than
um
Africa with 18 million people.
that's, yeah, something's a little wrong there. But I mean, I'm very glad for that you all are more thoughtful than the rest of us.
I
We
don't
don't.
know about that. Again, I wish we had all these solar panels doing good in Africa, and we would use for our electricity safe and nuclear power from a rational perspective. But I'm a rational person, right? I just look at the data and I say, this is much better, because the value of those same solar panels are much higher in Africa than they will be here. If it's all about
Yeah.
climate change and about doing good, you put those panels there, let them add value there, so they don't have to cut down the forest.
That is actually a really um that, although it would cost so much, an interesting plan. Like you'll often have these, like, buy one pair of these sneakers and another pair gets given to a kid who needs it, you know?
Mm.
You buy this one solar panel and we install one in Africa.
Yeah, I think there are some plans like that. But we could do it now they're not that expensive anymore.
Yeah.
Okay, Eli also wants to ask a question.
Okay.
Let me see. Where is he? There he is. Hi, Eli.
Hi there. So yeah, a couple of points, just kind of to amplify things more than anything else. You may have noticed in a comment to one of your tweets, somebody posted a really impressive fit to an exponential curve of the degree of warming that we've had, and I think, if that continues to hold, I don't think people appreciate, unless they've been listening to Climate Chat, really appreciate uh, just how dire the situation that we're in really is. Certainly, if 2026 doesn't break the 2024 temperature records, 2027 probably will, and there's actually a chance that 2026 will. So, what are your thoughts on, if not people, being woken up by that into being rational, at least the prospects for the needle moving, but given that it hasn't so far, with the truly extreme temperatures and all of the extreme weather events that we've seen in the last 2 years?
Well, to be honest, the more I experience all these records breaking and the responses, um, I get less of a sense that that will bring about much change, right? We see, in a way, we see more and more denial. I never expected, before I started working on this, that so many scientists would be denying the data, even their own data. They show this, they publish data, they show data, they write things down in a scientific paper, it gets peer reviewed, it gets published, and then they have the audacity to say the exact opposite things publicly, just spreading disinformation because they fully well know, because it's inconvenient, right? Or it doesn't suit the narrative of what they are communicating. It's not hopeful enough or whatever, right? And to me, that's really mind blowing. I can't really grasp why these changes. It's like Bush. If you like, we're talking about like the most.
Leon?
Yeah.
Leon, sorry, you just got all garbled and you're frozen.
Still?
Hear you, but visual
Yep.
is, yeah, it's, there was solar flare or something. I don't know.
Yeah, I don't know. I
Still, now you're back, your voice is back to,
Okay, I don't know why, but should be fine. I hear you.
now you sound fine.
Yeah. Again, I don't. Did you miss something I said?
Yeah, just I'm not sure where you dropped off, but it was like it was just 10, 12 words until I
Okay. Eli also left and joined again. I don't know. Maybe that's why.
Yeah, no, it's their servers.
Okay.
I suddenly got booted, I think.
Strange. Let me also minimize some screens here. Yeah. Did you hear what I said? What I said, Eli, or not?
I got most of it, I think. So yeah, it is kind of baffling. It's like, we must not reach the obvious but forbidden conclusion. Right?
Yeah, but even I don't know what came through, but it's their own conclusions now, right? Of course, like, they didn't want to believe what we publish, and even though we publish the data and we show the data, but now, and they cherry picked some data sets, and they said that we forgot about water vapor or whatever other ridiculous comments they made, which didn't have anything to do with what we published, right? It's like, of course,
yeah, that was sorry, that's where you cut out the part
But-
that they aren't even believing their own data.
They are, but they publish it in the peer review, or they don't read it, right? I think many professors don't read the papers their name is on, and like their names are so many papers, and I'm sure they don't read it.
It happens.
It happens a lot. But even now, it's like in the summary of this new paper published on ocean heat content, where it says, because of greenhouse gases reductions and increasing greenhouse gas and reducing aerosols, the ocean heat content increase is increasing, something like that, right? It just shows it, and they still don't talk. Many of them still like don't publicly, even like they, with great power comes great responsibility, right? They can reach millions of people, and they are not only not telling people about one of the greatest risks occurring in the history of our planet, the fastest rate of warming ever in the history of our planet, but even spreading disinformation about it, some of them. And I think that's really, really dangerous, right? And I don't think, like, what else do we need? Do we need like 2 degrees in 2017 or whatever? And will they like then? I think like if you're in the habit of shrugging everything off and saying it's just natural variability or whenever it suits you, I don't think like anything will dissuade you from that, because it's not rational. The data is quite clear. And
it's also not science.
No, it's not science at all. But it is not like these kind of comments, like those are on social media and in the media, right? And it's not because the science agrees, right? There's maybe some uncertainty of how much of it is feedback, how much of it is forcing or whatever, but the data is the data, and if you, of course, you can interpret it a bit differently, and that's what I did in a way. This one cherry pick data set that was saying the truth is bad enough, right? They didn't show acceleration, but then they changed it, and it now does show acceleration, but they don't talk about that, or someone doesn't talk about it publicly, and they don't change the defamatory blog about us because they don't. I don't know why, but it's dishonest.
Yeah. So, given that, what in your estimation are the best strategies available to us, both to as separate things to move the needle in the discourse, and to actually like do things, get ready, like we've been talking about solar radiation management a lot. Given the circumstances, what are your thoughts on how we advance that?
Yeah, I think what will happen, whether we want it or we like it or not, is that we will see more and more applications and businesses and countries starting to try SRM. And in a way, like India already does it by not reducing its sulfur emissions, right? It had these desulfurization regulations, so to reduce sulfur emissions from the coal plants, and it keeps postponing it. And now it seems like it says we're not going to reduce these sulfur emissions at all. And whether that's some rationale behind that or not, in practice it does continue the regional cooling of the sulfur emissions over southern Asia. And I think we will see, and that is the cheapest and the most, in a way, fastest way to do that. And we see that happening already. And I think that we might see that also happening in China, over the oceans. I don't think China will do that, but it might. Like how bad does it have to get? How many millions will die, and in an extreme heat wave, how many like billions of tons of food have to be wasted or destroyed by natural disasters before some countries will start to take very drastic decisions, right? And I don't think that will start with stratospheric aerosol injection. I think it will start more with regional cooling over the oceans and over land. And yeah, some countries like China and like in the Middle East, they already do cloud seeding, right? And they already do to make it rain, to try and make it rain. And so if they put different particles in the atmosphere, they could cool this things down. And I think I think, and in a way fair, that it will continue, because of course that it will also, to me, that like this Faustian bargain where our air pollution hides the real impacts of our greenhouse gases. It is there, and when it's unmasked, it's like there is some benefit to unmasking the Faustian bargain, right? To showing the real impact of climate change.
Leon, sorry. Again. Yep.
I don't know what happens.
Well, anyway.
Okay. Yeah. Do you have any more, like one more comment, Eli? Or Stacey?
Yeah. So the one is from Nevitz. I recently saw about 2 weeks ago an interview of an economist who was a bit more optimistic that we could transition to renewables, solar, wind, water, without, and of course there's debate over whether water is renewable or not, without too much pain, but we would have to go at the transition full bore now. And even without nuclear, I do not, and even without nuclear, I do not recall who he was. He sounded reasonable. And then later, I think they said Stephen Michaud, maybe. I don't know. Have you heard this?
Well, there's many people have been saying that we can power our civilization on renewables, right? It's, yeah, I don't know. Like we could do a lot of things, but like,
But will we?
yeah, it's, yeah, like like the data shows that we are still increasing greenhouse gas emissions every year, and even like, yeah, even the COVID-19 only caused like a temporary reduction in greenhouse gas emissions of I think about 8%. Depends a bit on the time period you choose, but it's, I don't see it happening, right? We talked about the Jevons paradox and about many things here in the past, and like that's what the data shows, is that we keep increasing energy. The more energy comes on the grid, like it's, we live on a global market. In a global market, if you can't sell your fossil fuels to Denmark anymore because they are powered by sustainable fuels, or Sweden or whatever country, yeah, it just goes on the market, and it's more affordable. And like I do hope that the prices will increase, maybe because of some disasters, and then that's what you, for example, saw happening in Pakistan when they, of course, there were all these solar panels, were the production capacity was there, but also because of the war in Ukraine, and we didn't want Russian gas anymore. And of course, the Nord Stream 2 pipeline was blown up, 110 billion cubic meters of gas per year. And then we switched in the Netherlands, we switched to liquefied natural gas, much more liquefied natural gas. We installed this enormous onboarding system, of course, because we have all these gas fields in the north, we have the infrastructure there. There's also, I visited this coal plant where they regasify this liquefied natural gas, because it's liquefied, it's like, and they need heat to turn it into gas again. So, and then because of that, the rich countries like ours, like, bought up all the gas. And then when Pakistan wanted to buy gas on the international market, they couldn't. No bids. Right? Nobody even wanted to sell it to them, or they because yeah, the price, they couldn't pay enough high enough price. So they bought all these solar panels, and now like it's like the fastest solar transition ever in the history, I think, of the world, right? On Pakistan. So there are some good examples. Ethiopia is another one where they like banned fossil fuel gas because, yeah, they don't have fossil fuel. It like really hurts their trading budgets, and but they do have a lot of hydropower and wind and solar potential. So they switch to, they almost jump. Like if you go outside cities, almost no one has a car in Ethiopia, but they will just switch from horse and wagon directly to an electric car.
That's a beautiful thing. Although I'd rather have there be electric bikes, but
Yeah, we could talk about that, but it's I agree. Like especially
yeah,
inside
we
the
would be a
cities.
great bike program.
I met this American guy in Bahardar in the north of Ethiopia, and he said a bikeable Bahardar, bikeable Bahardar, which is a small city in the north of Ethiopia.
Oh, okay.
And then
Nice.
yeah, very nice. But I had this meeting with him, and I think he was like 2 or 3 months there, and I had this meeting with him. So I asked like this guy at my hotel, like, can I borrow your bike so I can go to this meeting? So I was going there by bicycle as a Dutchman. For us, it's very normal to do that, right? To just take
Yeah.
a bike somewhere. Even our prime minister and our queen used to do it, and go by bike to work. But then he said, "Oh, you took the bike," and I was like sweating because it was like the middle of the day and it's really hot there, and it's not very high. Much for Ethiopia is highland, but Para is a bit lower. And it was really hot during the middle of the day, and I said, "Yeah, it's all out." And I asked him, "Did you ever bike here?" He said, "No." He like setting up this bikeable Bahardar program while he never rode a bicycle himself.
So does he work for an engineering firm or
No,
like what's?
he was like this professor on what do you call it, periodic leave. What do you call that?
Oh, sabbatical.
Sabbatical.
Oh, okay then. Interesting.
And I have more examples like that, but
That's crazy.
it's like, and I can say that, right? It's foreigners coming to developing countries and telling the locals what to do. Like, as you can see, I'm not originally from Ethiopia, right? So
I wouldn't have guessed.
yeah, but I do work there, and yeah, now there's a war and there's some. It's more challenging, but what's really like the locals know what works. We're not going to tell them what works. They know. If you want to know, ask them, right? Don't tell them what they need, but you can tell them what technology exists, right? If they
Yes.
don't know, if they don't like, if these electric bikes are not on the market yet, or the electric rickshaws or bajaj or whatever you call those three-wheel devices that transport people in these smaller cities. If they don't know that, but now they are, and they want to produce them there because otherwise they have again all these forex, these dollars flowing outside the country. So they want to produce locally or at least assemble locally. So that's important too. So you have to take all these whole market into account. Like in the Netherlands, we used coal because we had coal mines. Then we used the gas from the north because we had discovered this new gas field. Now we use wind from the sea and the solar panels because, of course, we have good trading and managing an infrastructure capacity. So we can import all this stuff from China and just build it. But still, we use like a lot of oil that's imported, a lot of imported gas. Even we are not there yet by long. Okay, I think we have to maybe two more questions.
Yep, that's all I have. And one's super easy. The first is from David Ulrich. How much of a role do aerosols play in cumulus cloud formation globally? Does the Clean Air Act speed up the poleward shift of storm tracks, as George Salutis references?
Yeah, that's a good question. So without aerosols, there wouldn't be any clouds, or virtually there wouldn't be any, because water vapor needs a condensation surface. So in aerosols, air pollution, sea salt, dust, sulfates, the solid or liquid particles in the atmosphere, that's where water vapor from the air can condensate and form solid or liquid water. Liquid water, raindrops, and solid is like these ice crystals and snow. And the more of those particles you have, the more condensation particles there are. So the bigger and larger the clouds are. So you, especially in these regions where you have a lot of water vapor, not a lot of and relatively low temperatures, and not a lot of condensation nuclei, then that those there the aerosols impact a lot. And it also depends a bit on the time of the year, etc. And then what you see is that it really depends where you do emit these particles. If you cool only the northern hemisphere, then those storm tracks, or those intertropical convection zone um, shifts. If you cool northern hemisphere, it shifts southward. And then if you warm it, or if you reduce the cooling of northern hemisphere, it shifts northward. And then so you have that. There's quite some research showing that it does play a role. How much is cloud aerosol forcing, or how much is feedback, and how much of the feedback is from warming and from changing cloud patterns or changing weather patterns? That's quite uncertain, of course. But the data shows, of course, that the increase, this increase in the rate of heat uptake, especially now with the North Pacific, is really. I think that share the graph. Is it still here? Yeah. So the North Pacific is warming now 2,000% faster than it was on average between 1960. Between 1854 and 2010, and after that it's much more.
2,000%?
Faster, yeah. Yeah, I was quite surprised by that number as well.
I guess that's, and if anyone's interested, we did a show on that called "What the Boop is Going On in the North Pacific."
I think, what the hell was it?
Okay. I thought it was just asterisks and whatever, but and then, well, the very last, very easy question that we have is from Robert.
1 second before.
Here. Oh, yeah. Oh, gosh.
So it depends a bit on which region you take. So of course you can change the latitudes a bit, and you might get a bit of different numbers. But this is what Zachary Leib used, and I just showed here. So about 0.4 degrees Celsius over 156 years. Of course, there's variability again. The volcano at the start, around the change of the century, more volcanoes, and some hunger, and then of course there's quite some uncertainty about this data, but like this enormous increase correlates with the decrease of sulfur emissions from China and from shipping, and I think it will only increase further because that's what the NASA satellites show, right? And that's worrying.
So well, okay, so this is going to be, elementary school level here. there is no PMOC, but it seems it makes me wonder, is energy sort of dissipated by the AMOC? Like, does that
Yeah,
help?
that's a good point. Yeah, there is indeed. There is heat transport between the North Atlantic and the North Pacific through the atmosphere. So that's, yeah. I'm not a atmospheric science professor, so I know some people who can talk about that much better than I can. But yeah, I think that there is a good yeah. So if you have more heat absorbed by the North Atlantic as well, the North Pacific warms as well, faster as well. So there is indeed these interconnections, as we call them.
Mhm. The last question is super easy. This is from Robert, and he wants to know, what is on the bottom of your chalkboard? A snowman or something? And what does the caption say?
This?
I don't know if it's that. I can't see the other side of if there's anything down there, but
That's your president. No, that's not your president. Your founding father. What's his name? The one. Wait, let me check.
they all have powdered wigs, so I don't know.
I confuse them as well.
It looks, oh, maybe Ben Franklin?
The Ben Franklin. Yeah, I think so. Take such measure as possible and practical to secure themselves. That's when he was talking about Laki, the volcano. Wait, let me check. I'm bad at names. Ben Franklin.
Yeah.
Yeah, that's what Ben Franklin was, the one of the first to realize the cooling impact of aerosols.
He was quite the scientist. He what's the thing we always learned? He had the something about lightning and that there's electrical power or whatever, and went in a thunderstorm or whatever, and flew a kite and had a key tied on the kite or something. And
Was
yeah,
that
I
Ben
don't know.
Franklin? No,
Yeah, I'm pretty sure.
he did that too.
Yeah. Oh yeah, he's a clever, crazy dude.
And
Um,
he developed stoves as well, heating
really?
stoves.
Oh, the Franklin stove. Yeah, that's the. I guess. Or are you teasing?
No,
I have no idea.
yeah, I think he has a patent. He patented that, and yeah, he did a
Okay.
lot. But so he was like, that was in 1783, and after that there was global cooling, and especially of course regional cooling, and he wrote about the link between the volcanic particles and the cooling, and he warned, or he said that we should take such measures as possible and practical to secure themselves against these climate phenomena, right? And of course, he was talking about cooling, but we also, yeah, now, and I think we should still really worry about potential very strong cooling, and also the food production impact of a very strong volcano. We should worry about them, and we should take measures for adaptation measures, and maybe even reducing those particles if possible with some technology. But yeah, of course, the main problem that we now is not that it will be too cold, but that it's too hot.
Yes.
Okay.
Okay.
Thank you, everyone. for listening. Please like and subscribe and share this video. You can use the same link as the live video to share it. And I hope to see you next week. Of course, as I mentioned at the start of this, we have a pre-recorded episode for you. Stacy, what is it about again?
Biases.
Optimism bias.
Optimism bias. Yeah. Because everything's going to be okay, people.
We'll be fine.
It's fine.
We'll be fine. So more about whether we will be fine next week. Thank you.
Excellent. Okay. Thanks. Bye-bye.
Bye.